So, all right, welcome. This lecture is being recorded. It is about Chapter 16, Investment Decision Applications. We have 3 sessions in Chapter 16. Session 1 will calculate the discounted value of cash flow between alternative investments on the basis of the discounted cash flow criteria. So discounted flow usually refer to the present value. That is session 1. And session 2 will calculate the net present value of a capital investment project, and then make conclusion from net present value to see if the project is acceptable, is feasible. Okay. So session 2 is about net present value, NPV. Session 3 will calculate the rate of return on investment. We usually use IRR, rate of return, sometimes also refer to internal rate of return. Okay, so that is 3 sections. This chapter is all about making investment decisions. And there are some principles. One is you need to consider the comparative effects of the alternative course of action on cash flow. So usually you are going to compare 2 choices or 3 choices. Cash flow analysis need to be taken into account because because of the time value of the money, the interest. When we make the decision, we usually compare the discounted cash flow. It is also called present value. The net present value method, NPV, indicates whether a project will yield a specified rate of return. So those are some concepts. When you evaluate capital expenditure, you need to estimate all future cash flows. Okay, anticipate all future cash flows for the project. And also you need the interest rate. If you don't have one, you can assume one. And then make adjustment based on the assumed value. Next, you calculate the present value of these cash flows. Why we need to calculate present value, not future value? Because we need to make a decision on the investment in the beginning, not at the end. And the decision has to be made before the resources are invested. That's why we need to calculate the present value, not future value. From a mathematical point of view, to evaluate the capital expenditure, it is all about time value of money, means interest. $1 per day is different from $1 yesterday or $1 tomorrow. So now that is the overview of chapter 16. Now we are going to present session 1. Session 1 of chapter 16, discounted cash flow. We have some principles to observe. One is cash in hand principle. Remember, in the current financial situations, people are talking about cash is the king. So it means given all other factors are equal, early benefits are preferable to later benefits. This is true especially during the economic turbulence, uncertain times like the times right now among the COVID-19. Okay. So cash is the king. The second principle, the bigger the better. Okay. We prefer bigger benefits than smaller benefits. This is common sense. Okay. Either bigger or small, you have to compare at the same time point. Usually, we use present value or discounted value. Now let's take a look at an example. An insurance company offers to settle a claim by making a payment of $10,000 immediately or $3,500 at the end of each year for 3 years. Assume money is worth 6% compounded annually. Which plan would you accept? There are two plans or two alternatives. Alternative 1, would you accept $10,000 today? Or would you accept $3,500 for 3 years? Which one would you accept? And this $3,500 is at the end of each year. And the interest is 6% is given. And how do you approach this problem? We use discounted cash flow. Discounted cash flow means we need to calculate present value of this annuity. This is a simple annuity. 3,500 formed an annuity. This 3,500 is PMT. Okay, so for alternative 2, after we calculate the present value of the annuity, and then we compare this present value with alternative 1. Alternative 1, 10,000 is the present value of today. Okay, and then we follow the bigger benefit. We prefer the bigger benefit. Which one is bigger? That one is our decision. Okay. So now I'm going to calculate the present value of this annuity, 3,500. For this annuity, I need to set up my computer PY equal to 1 because it is each year, and CY is 1 because interest is compounded annually, and it is at the end mode, your computer end mode. And then N, term N equal to 3, interest rate 6%, and then you compute PV. So that is the method. Okay. So I'm going to, I have to, can you see my calculator? Maybe not. So I have to switch to share my applications. Can you see my calculator? It is all right. Okay, I'm going to, I'm going to share my calculator as well. So I'm going to stop sharing, start sharing again. Instead of application, I need to share my entire screen so that you also see my calculator. So can you confirm you can see my calculator and my screen? You can see both. Let me see. Did you? Okay, great. You can see both. Thank you for confirmation. So I'm going to clear second quit. Make sure my calculator is at the end. Okay, there's nothing on top right corner. This is at the end. Now set up PY equal to 1. Press enter. Use down arrow key. CY is 1. Enter. Second quit. And then enter 3,000. $500 negative PMT. 6 IY. 3 is term N. Always remember you need to enter 4 numbers. Right now we have just entered 3 numbers. We need to enter 1 number, 1 more number. 0 is FV. Final step, compute PV. So this is our number. Okay. Since we calculated the present value, we compare the present value with the alternative one. So the final conclusion, we would accept alternative one. So we would accept a lump sum of payment 10,000 because it has bigger benefit. Okay. So this is a calculator method. And you can also use formula. Okay, you can also use formula. When you use formula, this is the formula for annuity, PMT equal to, I'll write down here so that you can compare. Oops. So the formula for PV for annuity, simple annuity, PV equal to PMT times bracket 1 minus 1 plus I raised to power negative n over I. You can use this formula to calculate present value. Okay. And then you make decision. Okay. So this is an example about discounted cash flow to compare two investment decisions. Okay. All the examples presented here, you can connect them with MyLab questions. MyLab questions are actually based on the textbook questions. They're all connected. So now let's look at this example here. ACME printers need a new machine. It can be purchased for $8,000. And after 5 years, we'll have a salvage value of $2,000. So this is one alternative. You can purchase for $8,000. After 5 years, the machine has salvage value $2,000. Another method, alternative is the machine can be leased for 5 years by making monthly payment of $130 at the beginning of each month. If money is worth 5% compounded annually, should you buy or lease the machine? This question is very practical. When you purchase a big item, for example, when you purchase a washing machine or a big TV, you may face the two options. Do you want to buy or you lease? Okay, do you buy or do you lease? Even for the house, right now, do you buy a house or do you lease a house? Same principle. You just change the numbers. Okay. So how do we do this, approach this question? Again, we follow the same principle. Discounted cash flow. Okay. There are two alternatives. Okay, two alternatives. Alternative one is to buy the machine. When you buy the machine, you have to pay $8,000 up front. After 5 years, this machine is worth $2,000. Okay. So based on these two numbers, you calculate the present value. The present value of this decision is to calculate this 2,000 is FV. You have to calculate what is the present value of those 2,000. What is the present value of the 2,000? And then you subtract this from 8,000. And this one, the formula, so is the formula PV equal to FV times 1 plus I raised to power negative n you can get this PV. Another method, you can use the calculator for this PV. So I'm going to second quit. When you use calculator, so PY is 1, CY is 1, and then future value is 2000. Is the future value. 0 is PMT. 5 is interest. 5 is term N. Compute present value. So you get this number, 1567. Okay. So I will write it down for your future reference. How do you calculate this number? This number using the calculator. You set PY equal to 1. CY is 1. And then 2000 is FV. 0 is PMT. 5 is IY. And is term N. Compute PV. And you will get this number. Okay. And my computer is based on the AND mode. So this is how you calculate the present value of 2000 and then subtract this present value from 8000. You get the present value of alternative 1. Okay. So now let's look at alternative 2. Alternative 2 is from ORR means alternative 2. You lease the machine for 5 years by making payment 130 at the beginning of each month. That is alternative 2. So for alternative 2, that is the annuity. Okay, that is the annuity. And you have to use the general annuity because the interest rate is compounded monthly. Interest rate is compounded monthly. So let's do calculator method, then we come back to this formula method. Okay. Let's see. So let's go back. This is the original question. So I'm going to use calculator to calculate the present value of the annuity. Present value of the annuity. For the present value of annuity, PY equal to 12. Because you make payment every month, 1 year you make 12 payments. CY equal to 1 because interest is compounded annually. And your calculator, BGN mode, BGN, your calculator. And then N equal to 5 years times 12. You see, we actually constantly review the previous chapters. So That's why chapter 16 is very important. So n is 60. Okay. Interest is 5. Okay. So we need to calculate the present value of this annuity. Go to second quit. Make sure the computer is at begin mode. Remember how to set up begin. Second, begin. Second, set. Second, quit. So now you have begun, BGN. I repeat, second, begin. Second, set. Second, quit. You get the begin mode. And then second PY is 12. Enter. Use down arrow key. CY is 1. Enter. Second, quit. So I set it up the computer, I mean calculator. And then 60 is N, term N. 5 IY 130 negative PMT. We have entered 3 numbers. Remember, we need to enter 4 numbers. 0 FV as a precaution to clear any previous entries. Final step, compute PV. And we get this number. Okay. So this is this method, calculator method. Okay, we get this number. And this number agree with the number we get from formula. Okay. And for the formula, you need to know the equivalent rate. Okay, you need to plug in this number. Okay, so you need to calculate P. Remember what is P? P equal to 1 plus I raised to power C minus 1. And what is C? C equal to CY over PY. CY is 1, PY is 12. Okay, so P equal to 1 plus I is 5%. Raised to power 1 over 12 minus 1. So I'm going to use Excel to do this. So equal 1 plus 5% raised to power 1 over 12 minus 1, that is a P. Okay, so 0.047. So I'm going to copy this over here. So this result equal to 0.0047. Okay, so once you calculate P, equivalent rate per payment period, you can use present value. So it is a PMT, present value PV, equal to PMT 1 minus 1 plus P raised to power negative n over P. So that is the present value. Okay. So far we did the present value for leasing. When you lease the machine, the present value is this one, $6,935. Remember, when you do the purchase, when you to buy the machine, you need to pay $6,432. So obviously, which one should you make? Should you choose to buy the machine or to lease the machine? The decision is to buy because it costs less. If you lease, it will cost more. Okay. And my lab have similar questions. So that's why I strongly suggest you do the examples presented in the lecture and the textbook very proficiently. Okay. You redo this one and make sure you can come up with the present value for buy the machine, the present value for lease the machine. And so this is the decision. Buy the machine will cost less. When you do the present value of cash outlays, so now we introduce a new concept, net present value. Net present value. It is the present value of inflows, money in, minus present value of outflows, money out. Okay. And how do we know the net present value is positive? When you have money in more than money out, you have a positive NPV. When money in equal to money out, you have a 0 NPV, net present value. When money in less than money out, you have negative NPV. Okay. And also we have the criteria rule. We are going to accept those capital investment have a positive or 0 net present value. We reject those projects that has the negative present value because you're losing money. Okay. And if you have a rate of return is given, we are going to accept the project if net present value greater or equal to 0. We are going to reject the project when the net present value is negative. Okay. So that is the criteria. So we finished session 1, discounted cash flow. Let's take a break. After break, we'll do the net present value, session 2 of chapter 16. Okay. So I'm going to go back to stop recording. Any questions?